Hello. Hi, everybody. We're going to give folks a couple of minutes here to wander on in, and then we'll get started. Thank you for joining us today. To those of you who just came in, we're just allowing a couple minutes for additional folks to make their way in, and then we'll get started. Okay, tell you what, let's go ahead and get started. The number looks to have normalized there a little bit. Welcome to today's CNCF webinar, Getting Helm to be Enterprise Ready. My name is Ariel Jatib. I'm a founder at a company called StackPoint Cloud, where we make it really easy for you to deploy and manage cloud-native tooling at a variety of the leading cloud providers. I'm also a CNCF ambassador, much like our presenter today, Baruch Sadorski. I think I got it there. I struggled less with it, I feel, when we practiced beforehand.
Only the last time counts, so it's all good.
All right, we got it. Thank you all for making time today to join us. Baruch comes to us from JFrog, and he's going to be sharing with us some of their expertise on Helm with you today. A little bit of housekeeping during the webinar. If you're not going to be able to speak as an attendee, there's the chat window. Feel free to add your question there, and then we'll go ahead and pass those on to Baruch once we have a natural kind of break in it. There's also a Q&A function down there, so feel free to also submit your questions there. Let me tell you a little bit Baruch, who is our presenter today. He's developer advocate at JFrog, and a fellow CNCF ambassador. His passion is speaking about technology, and speaking in general, but doing it about technology, he feels makes him look a little bit smart. And with 17 years of high tech experience, it sure helps. So when he's not on stage or in Sunnyvale, he's usually on a plane on a way to a stage someplace else. So we're very excited to have him here today. And without any further ado, I'll throw it over to him to lead us into the topic.
Thank you very much for the intro, Ariel. Yeah, so we're going to talk today more about the development of Helm or architecture of Helm than Helm itself. So I hope that's that topic will be of an interest. As Ariel already introduced me, my name is Baruch. I'm developer advocate with JFrog. What's going on with my slides? They are not. Oh, here you go. And that perfectly describes me. At Jabarch on Twitter, as you can see right in second slide, very entertaining guy, definitely worth following. In case you forget, I have the Twitter handle on every slide, so you can keep up. Yeah, that's actually fresh screenshot from today. I've been added to the this great bunch of people who are CNCF ambassadors, and I'm really proud to be there. So thank you, CNCF, for honoring me being your ambassador. I hope I won't let you down. I want to start with a poll to kind of calibrate the level of discussion first. So my question to you will be, what is your knowledge of Helm? I don't see the poll, but it doesn't mean that you don't. Do you see the poll? Yeah, okay, and now I see the poll. Right, so just to understand where we stand, let's give it like 45 seconds. And maybe we can share the results. Let's see what we got. Okay. Well, that's a very nice distribution. It's like a perfect bell curve. Most of the people played with Helm a little bit, and that means kind of a mid-level of discussion. That's a great. None of the Helm authors creators are here with us, which are great news, because then it will be less chance of embarrassing myself. For the couple of folks that never heard about it or don't have enough knowledge about it, don't worry. I will do an introduction, and for the power users, don't worry, it will be a quick introduction. So I guess that covers all of us. So let's dig into it, and let's talk what the Helm is Helm. It is a dependency manager for Kubernetes, and it solves the problem that is described here. So before Helm, or in plain Kubernetes, what do we do? How do we deploy anything to Kubernetes? We find the YAML files and documentation, but usually just Googling it and stumble upon, and then we copy them, we paste them, and then we fix intents, and then we repeat. So that's kind of our life deploying stuff into Kubernetes, and that's of course very annoying. The other problem is this is like a normal Kubernetes resource. I bet most of you at least seen it at least once, and this is how it looks like. And note how you have the version here embedded in the spec of our container. That's our Docker tag. That's the version of our application. So now we decide to build a new one. So we do Docker build, and we tag it with the version 1.1. And the last thing that we need to do is to update the version inside our Kubernetes deployment YAML file. There are a couple of ways to do it. One of them is running the set command. Well, that's, you know, we've seen better commands in our life. Uh, the other option would be just use the latest, and you know, that's a great idea. Always using latest. I mean, what can go wrong when you use latest? Yeah. So you got it. Both options are suboptimal. Let's put it that way, or plainly suck. Helm solves both of the problems of copy paste, fixing intent, and the problem is, well, how the hell do I update my charts? Sorry, how the hell do I update my descriptors once I have a new version? And it does it by encapsulate packages of Kubernetes deployments. And I have here an example of one of our products, JFrog X-Ray. You know, bunch of microservices, stuff like service for analysis, event ingress, indexer, storage server, persistence layer, all this stuff. Each and every one of them is a Kubernetes deployment. It's bunch of containers wrapped up in Kubernetes deployment. So before Helm, if I wanted to deploy X-Ray on one of my machines, I had to deploy all those and actually know which versions will work with which additional versions, etc., etc. But once I have a Helm chart, I can encapsulate all those deployments into one chart. I just say X-Ray, and it actually knows which deployments it consists of. And that's a big deal. Another very important benefit of Helm is a templating engine for descriptor files. So remember how we hard-coded the version and then didn't find a good way to update it. All this is done with Helm. We can use templates and then provide values into it, and we can provide values from multiple sources, and they take precedence one over another. So we can have a values file that will have kind of defaults and stuff that we don't want to update in the runtime, or we can have dynamic versions that will come from our command line or from variables, and they will override the default versions that we provide. Another very big benefit of Helm is how simple it is, right? So you look at the Helm chart, and that's an example of Docker app, the same Docker app we spoke about in the Helm registry, and we see that it's actually just an archive in which we have predefined directories like the templates, which have a bunch of templates, like the deployment one, the one that I showed you earlier, and then metadata like the chart yam, the README file, Jenkins file is if needed, and then values. And this is pretty much it. It's very, very simple. So it provides us with a very simple way to get started because how simple it is. Look at this index YAML here. It actually resides in the root of the repository, and we are going to talk a lot about this index YAML down the road. Once we have those templates, we can actually reuse the same chart for multiple application versions, right? If we template the application version, we can generate different deployments by just replacing the version in the chart template. But so what it actually means is that we have multiple versions of application that can be deployed using the same chart version. It sounds like a very right and good idea, but then it actually requires you to provide a version of the application each time you want to deploy something using chart. Because if you want just to deploy something like we did in the X-ray example, and you want to install X-ray and you do Helm install X-ray and don't provide a version, the version will be taken from the values descriptor. And the values descriptor, as you remember, is a part of the chart itself. So although we can use our templating agent to have one chart version to serve multiple image versions in our deployment, it's actually not very uncommon to have a relationship of one-to-one. When you have one chart that has one container with a tag, one image with a tag, and you still use templates, but then the value is hard-coded in the value document, which the descriptor, which is a part of the same Helm chart. So there are different approaches, but what we will see more frequently than not is that actually you do have a chart file every time you change the image or the content of the image or what's not. And I'm kind of, I speak about it a little bit because as you can see, as you will see later, it has a great impact on the performance of Helm. We're going to talk about it. So this is on the descriptor and the chart as a package level. Talking a little bit about the architecture of Helm itself. Helm not only is a package manager that can download, resolve, or search packages for you, it also takes care of a deployment of those Helm charts into your Kubernetes cluster. So there are two parts for Helm. The one is Helm client, and that's what you run on your machine when you run commands like Helm search um, to find what you need, or Helm pull to actually download what you found. But then you can actually install it using Helm install, and this is where the client is going to communicate with its counterpart, which is called a tiller, Helm tiller. And the tiller is like the steering part of the boat. So I guess our word of analogies with boats continue here. We have a tiller that will make the install of the Helm chart inside your Kubernetes cluster. The tiller will communicate with your kube control command and will make sure that all the deployments that are part of this Helm chart are actually installed into your Kubernetes cluster. Right, so two parts: the client, local chart development, when you write those descriptors and then you want to pack them into being a chart, you do it on your client machine. This is why it's a part of the Helm client. Managing repositories. Which repositories do you want to pull your charts from? To which the repositories do you want to push? All that managed on the client as well. And interacting with the tiller server, sending commands like install. Server, listening for incoming requests, install requests, update requests, etc., and then combining a chart and the configuration to build a release, something that need to be installed, and then installing charts into a Kubernetes cluster itself, and then tracking the release, for example, to figure out that updates are available in your Helm repository and need to be installed in your cluster, and then taking care of upgrades themselves, and also, of course, uninstalling, etc., etc. Right, so that's kind of the architecture. A brief overview of which commands are available when you work with Helm. Again, very, very simple and intuitive stuff. Helm init, actually goes and installs the tiller and configures the client to work with it. Helm Search downloads the index from the repository and searches the index for the Helm charts that you look for. Helm install sends charts to your Helm tiller and asks it to provision the deployments within the chart to your Kubernetes cluster. Status will give you a picture of which charts are installed and whether they are of the latest version, comparing to what is found in the repository by using the index that was downloaded previously. And Helm repo actually provides you a command for working with repositories, specifying which repository should Helm client interact with when it searches, downloads, etc., etc. And speaking about repositories, there is an official repository, cubeapps.com. You go there and you can see the charts that are available. There are here in the official one that's pretty old, I think, screenshot a couple of weeks ago, 160 charts. Artifactory is right here on the first line, so I didn't have to scroll down to take a screenshot. It's all good. There are also a list on the Kubernetes on Helm GitHub repo as well. So that's the official repository, but as normally with repositories and registries, you really want to have a local one, both in terms of, you never can trust the internet, so you want a local cache, and also you want to write your own Helm charts, which are not public, and you are not going to deploy them to the official repository, so you should use the local repository for them as well. Extremely simple. As we spoke about, the structure is very, very simple. So creating a repository is very, very simple. You can run an HTTP server in 2 lines of code or in Express.js or something, and just have the index YAML deployed to it alongside the charts themselves. And you use actually a Helm repo command to generate this index. Option number 2, which of course we can highly recommend, is using artifact repositories like JFrog Artifactory or others. Those guys pay me money, so this is why they're called by name. Artifactory, for example, is a Kubernetes registry which supports both Helm containers and everything inside those containers as well. There are others which provide an out-of-the-box Helm repository as well. So this part kind of covers the introduction to Helm, and again, I hope people who never heard about it got their idea what it is, and people who are pros and power users didn't get too bored in a way. Now let's have fun. And that's my favorite VN diagram of all. And it actually shows you the relationship between the software that I like and software that I know really well. And that's true for Helm as well. Well, for Helm, it's kind of closer because although I think I know it pretty well, I still like it. But there are definitely places to improve, and we're going to talk about that next. So first question is, what do dependency managers and printers have in common? I probably should produce a poll for that, but that's kind of a rhetorical question because both of them are sent from hell to make us miserable. In case you didn't follow this Oatmeal comic, it's extremely hilarious, as all the Oatmeal comics. So you go ahead and read that after the webinar. But now let's talk about how horrible package managers are or dependency managers are. And Sam Boyer, he's a pretty known in our community as one of the authors of one of the proposed Debian sorry, Debian, Go dependency managers. I think he worked on GoGet, if I remember correctly. Before he started, he wrote, oops, sorry about that, this hilarious blog post on Medium, which is called "So You Want to Write a Package Manager." Should go ahead and Google that and write it. Basically, you woke up this morning, roll out of bed, and thought, you know what? I don't have enough misery and suffering in my life. I know what to do. I'll write a language package manager. He's talking about language. It's absolutely the same for any package manager at all. Package management is awful. You should quit right now. Package management is a nasty domain, really nasty. On the surface, it seems like a purely technical problem, but people approach. But there are people that actually make it worse. Software is terrible. People are terrible. There are too many different scenarios. Nothing will really work for sure. It's provable that nothing will really work for sure. And our lives are meaningless perturbations of three-link vortex of chaos and entropy. And you get into this realization once you work on package manager, and that's actually the case with any of them. Uh, the reason why I'm talking about it is that we are dealing in JFrog with package managers for the last decade, and we saw them all. We know how horrible any package manager in the world is, and they kind of fall into one of the seven deadly sins, one or more, usually more, of the seven deadly sins of package managers. The one is over architecture. There are very, very sophisticated and very complicated package managers that fall on short on doing the simplest things, or they're just too complicated to work with. Another kind of disadvantage of some package managers are they are not thinking when they are created of enterprise scenarios, and we end up with pretty basic stuff missing completely. For example, there are package managers that just don't have any way to have a private repository, because everything should be open source, everything should be on GitHub, and if it's not, we don't care about it. And that's, of course, a horrible approach. Another sin is having downloadable index. We're going to talk about why downloadable index have more downsides than actually pros. Cross-site dependency resolution loopholes is the way that when you as an enterprise try to control where the dependencies come from, actually every developer can override it and bring whatever dependencies they like from whatever place in the world they have. Author authentication done wrong when you have a central repository full of packages that you have no idea who actually wrote them, and that's of course can be very, very dangerous. Version management, or more precisely the lack of thereof. There are package managers that don't have this notion of version for their dependencies, or can rely on stuff like latest. And here, Docker, that you all obviously know and love, is a profound example. You can just say extend from some base image, and it will take the latest version, whatever it is, and it's a horrible, horrible idea. And using the wrong place for central registry, and especially hard coding it. And here we have also a lot of examples, stuff like a lot of package managers that kind of hardcore GitHub as their registry, and there is no way to change it, and that's also a very, very bad idea. So every package mentioned in the world suffer from some combination of those sins, and the ones that we like the most, like Helm, we are actually trying to help and cure them from those diseases. And with Helm, one of the examples of our contribution during the Helm Summit a couple of months ago, by now, yeah, February, we have our own Ankush, our solution architect, talking, giving some ideas of how to fight some of those problems. It was very well accepted. There are results that I'm going to share with you now. By the way, if you want to work on stuff like helping Helm get better or whatever it is, we're hiring like crazy, so you worth taking a look for. And this is a lot of things Helm did right. So as you can see, 5 of the 7 deadly sins do not present in Helm. For example, the central registry is in buckets on Google Cloud Platform. That's the right way to place it. You can configure which repositories you want to use and proxy Helm packages. This is also very good. Helm requires versions on the dependencies, so this is fine. Authentication is done by a public profile, usually GitHub. Also very good, good choice. You cannot provide a link to any dependency inside your Helm chart. Instead, you provide names, which guarantees that they will come from a trusted source. And as I mentioned, over-architecture is definitely not one of Helm sins. It's simple, and that's a good thing. There are 2 aspects that can be improved. One is enterprise scenarios. We're going to talk about that. And the other is having a downloadable index, which we are going to talk as well. So enterprise scenarios, what we had in mind is what do you need? Having an in-house registry, checked. We spoke about that. Using authentication and authorization. That's because enterprises actually want to have control of who can download what or who can deploy what, and that's for authentication, to know who wrote what. And then authorization is, of course, giving permissions for certain people to do certain stuff. I don't know what's going on. They have like, there are some celebration, probably some good news. Maybe it's because me becoming a CNCF ambassador, I'm not sure. People are celebrating all day long. Right. Segmentation per object, per organization, per project, per team, with central management. So we'll probably have some administrators of our organization-wide or company-wide Helm repository, and then we need to segment it per different levels. This is something very important as well, and promotion pipelines. So today we are not going to talk about the later 2 because they are just features of the repository itself. Factory supports both, not the topic of today's discussion. Instead, we're going to talk about the second topic, which is authentication and authorization. Well, it's a very simple story with it. Helm didn't have it, and now it has it. We submitted a pull request to support authentication, both base and SSL. It was accepted 2 weeks ago, exactly 2 weeks ago, 14 days ago. And next version of Helm will include the support for authentication, which any registry or repository can benefit, not only Artifactory, of course. So that's one thing. And this kind of covers the topics of having Helm Enterprise ready. The other one is scale. Now, when we have it enterprise ready and we deploy it on the enterprise, usually the load increases, especially in our biggest customers. And now let's talk about that. The topic of the discussion is downloadable index, good or bad. So there are some obvious good things about downloadable index, stuff like simple server. Spoke about it. You calculate the index on the client, and then you have a file that you need to make available of your HTTP server, and you're done. Simple server is a very big advantage and actually a very good way to start. Another benefit is offline search, which I'm not quite sure how useful it is, because, okay, now you downloaded your index. Let's pretend it's up to date. Again, we're talking about Helm being crazy popular. There are tons of new packages tons of new charts being deployed every day, index will become obsolete very, very fast if you are offline. But let's say you just downloaded the index, you cut your connection, and then you can search. Fine, you found the package that you need, and then what? If you're online, you cannot download it, and then, I don't know, all this use case of offline search doesn't make any sense. And the third kind of advantage of a downloadable index is offload the search load of the server to spare computer power, because the searches are then performed locally on the client machines. And I guess that was the reason why the whole idea of downloadable index was invented in the 60s, in the 70s, or whenever the first package manager thought of this great idea. But, well, I don't know, it holds today. The server will be powerful enough to perform searches for everybody. And if we don't know how to do it, we can ask Google. They are they manage this problem really, really well. So I don't think that offloading the search should be a big advantage. On the disadvantages front, we have, of course, obsolete index, and stuff is getting deployed to the server all the time, and my search becomes obsolete very fast. And the more importantly is that index becomes a bottleneck, especially if it designed not in a scalable way. And the problem with Helm is that index is a bottleneck. So we have here some benchmarking that we did, and that's a correlation between number of charts that exist in the search in the index on the server and the memory consumption. So you can see here that when we deploy a reasonably big amount of charts, what it is, 120,000 charts, we actually go through the roof in our memory consumption. And here's where you ask, are you nuts and insane? How will we get to 120,000 of charts? And this is where I remind you our discussion about the relationship between the chart and the containers within the chart. If we want a seamless Helm install command, we will have to hard code the version of everything inside our chart into the versions YAML, which is a part of the chart. And that means that every change in any bit inside one of the packages that go inside any of our containers that are part of our Helm chart generates a new version of chart. So yes, we will have a lot of charts through the roof. And especially if we are considering now a central repository and not an in-house repository, this is going to be out of hand very, very quickly. And of course, you can consider use cases such as NPM registry and Maven Central. The number of packages in those popular central repositories are huge, and we of course predict a Helm repository to be one of the big ones. So yeah, it's not gonna scale. Now the question is, how can we fix it? There are two kinds of fix. There is very quick one, and it kind of helps, and that's we can compress the index in transit. Frankly, this is so easy to deploy. I'm a little bit surprised it's not done yet. And it will fix some of the issues, namely, of course, the bandwidth and the latency of downloading the central index, but it won't solve the problem of managing those huge index files, both on the server and on the cloud. So the most scalable solution will be distributing the index. Now let's take a look at the index and try to figure out what we can do in order to build it better. So that's a snippet from actual Helm repo index. And you can see here that what we have are three different parts in one index. So we have an entry per application, in this example, Artifactory, and then we have a lot of metadata which actually relates to a certain version of this Helm chart. In our case, that will be a version 6.2.5 of the Artifactory Helm chart, which relates to an application version, Artifactory version 5.8.3. And those are getting repeated for each and every different version of our Helm chart. So below we'll have a lot of entries refer to Artifactory as well. And some of the information will repeat itself in each and every one. So for example, stuff like description. So you can see here, description, universal repository manager, and then again, universal repository manager. Why? Because the description won't change over versions. The same goes with keywords, with maintenance, with sources, because the sources are just the root of our GitHub repository, etc., etc. So what we see here are three different types of information combined in one. There is a list of which applications exist, and that will be the Artifactory one. There is an information, actually metadata, not an index, per an application, stuff that you want to know about Artifactory Helm chart, the description, the home URL, the sources URL, the maintainers, etc., the icon, probably not going to change, this kind of stuff. And there is another set of metadata, also not an index, a metadata about the particular version. And this stuff like digest, obviously, and the URLs where it can be downloaded. This changed by the version. Right, so what we can do is we can divide all three of those components to different parts, to different files actually, and then have a main index, which is actually an index. It will list all the charms with the latest version. So for example, it will list Artifactory 5.8.3, or sorry, I think that's the wrong version, but the latest Helm chart version, not the application version. And then we will have the application index, which will list the versions that exist of Artifactory Helm chart and the metadata that describes an app, stuff like description, maintainers, keywords, etc., etc. And then a version metadata file that will have information about this version, stuff like the version of the chart, the version of the app, when it was created, what is the digest, and where should we download it from. In this way, we have a distributed index. So for the search, all you need to download is this main index, which will be a fraction of what it is today. It will only list the entries for the apps. And then if you want to get info about the app, you will run a command like Helm info Artifactory. You will actually download the second part, which is the information about the app and the available versions of it. And then if you want to install a particular app, you will actually fetch the descriptor for the particular app, which will have stuff like, okay, where do I download the binary of this app from? And that solves the problem that we spoke about. Now, it introduces a new requirement, and this new requirement now is a layout inside the repository, because now when we have three different types of index and metadata files, we need to know where to find them. So this very nice and simple layout, we have a root directory and just a bunch of these targz files and one index won't hold anymore. So that means that we will need a layout like repo, in which we'll have the top level index and then a directory for our app. It will be called Artifactory in our case, and then we will have our application descriptor and then directories per each and every version, in which we will have the version descriptor and the binary itself that is our Helm chat for this particular versions. The downside of having a more complicated or more evolved structured repository or layouts is, of course, that it complicates the push command, because at the moment there are no push. If you remember, I showed you the list of Helm commands. There is no push in it because you don't need to. You just do curl upload or with post HTTP command, and you upload the root. You upload your Helm to the root of the repository, and you're done. But when you have a layout, it complicates a push, because you need to know the internals, the implementation details of this layout in order to push files. And one of the bad examples in this report is Debian packages, which actually do have a structured layout repository and more than one, but don't have any push built into the client, into apt-get. So you actually need to figure out what is the structure of the layout, which is the correct one for your particular use case, and then do the curl command by constructing this particular layout. We don't want that. We want to encapsulate the details of the layout and provide a push command to our users, and that requires adding Helm push to Helm. Helm push command to Helm, and today, as of today, there are discussions on how to do it, and you can see obviously the rationale behind it. Several registries have merged with support to Helm chart, including JFrog Factory and others. And the registries are asking and could benefit from a capacity to push packages from the Helm client. And that's the main driving force, is that if we're going to do something with the layout, we need the ability to hide the complications of the layout into this command. So this is actually what's going on now. That's proposal. It's on Helm's GitHub. If you want to participate, you can go ahead and participate in discussion. We are going to get into implementation details later, but the implementation is pretty straightforward. We will have a default HTTP push that will respect the layout, and we'll be able to change the layout once we progress with the index decentralization that we propose. Another very good reason to encapsulate the push is the ability to transit from a central index to a distributed index without disturbing the users. We can encapsulate the knowledge that the layout shifted and support the old layout for a while, all because we will have our push encapsulated into the Helm command. So this is all. Those are the three topics that we in JFrog hopefully help Helm community to improve and actually get rid of all the deadly sins of package managers. I really hope that one day Helm will be the example that I will give when I speak about how horrible package managers are, and I will give a counterexample that we do have a good package manager, which is called Helm. The gaps are not so big, and hopefully that will happen. Before we will get to to answer some of your questions. Just a shameless plug of our user conference that comes upon us in less than 2 months, in the middle of May. Napa Valley people. I don't know if I need to add anything else. Conference was all stay in a resort, a lot of wine, and I don't know if any of the content even matters after what I just said, but if it does, there is tons of CNCF related content swamp up. We're going to talk about gazillion flavors of Kubernetes on OpenShift, on Azure, and on AWS. We're going to talk about interesting integrations with Rancher, with other platforms. Of course, a lot of Helm, building pipelines with Helm, CI/CD, and working with Helm on Azure, and actually our very own lessons learned from working with Kubernetes and Helm, because we have pretty interesting use cases to share with you as well. So with that shameless plug, thank you very much. And Ariel, back to you. It's time to take some questions, I guess.
Yeah, thank you so much for that. And so let's lead off with a pretty high level question. Paul asked what the relationship is between Helm charts and a Docker registry and how they work together. So can you give us a quick summary of that?
Yeah, of course. That's a great question, and that's actually kind of related, but unrelated. They're related because they are both dependency managers for eventually container technologies, Kubernetes, and all that. The difference, Docker registry is a registry for Docker package management. It holds Docker images that we instantiate containers for, either for Kubernetes or for any other reason, although by today there are not much other reasons. But it only deals with Docker images. Now, Helm repository on the other side is the same idea. It's a repository for a package manager, and the package manager in our example is Helm. So there are different structure, there are different index, there is a different artifact type, Docker image versus Helm chart. Now, of course, it would be beneficial to have both of them in the same repository, because then, for example, you can set up metadata, and generally you don't want to manage multiple repositories, and that's exactly where JFrog Artifactory and alike can help. I hope that clarifies.
Okay, Paul, feel free to chime back in if you have some follow-up. And let's dig a little bit into that. So can you speak a little bit into the relationship between the chart version and the app version? On a somewhat related note, Sebastian asked, what about not changing the chart version when the image version is changed because they are a different life cycle? Is it
Absolutely, yes. So that I tried to explain, but probably didn't do a very good job since there are questions. So you remember this. This is a Kubernetes resource which actually hard codes the version of our image. And that basically means that every time I have a new version of my Docker app, I need to have a new version of my Kubernetes resource. And that's a bad thing because, well, it's not a bad thing, it is what it is, but it kind of limits me to one-to-one relationship between Docker image and Kubernetes resource. Now we step into Helm and we say, hey, but Helm actually helps with that because it has all those wonderful templating, right? So what it looks like is that I can use this template for serving multiple multiple Kubernetes resources, which essentially means multiple Docker Docker images. Right, so far so good. That's exactly what it means to solve. So for example, if I have here my Docker app version 1, I can use the same Helm chart to serve my Docker app version 1.1. But if I want to keep this template here, I need to provide value in some point of time. I can do it when I do my chart, my Helm install command, when I install my charts. But then I need to specify version. I will run the same Kubernetes, the same Helm chart one time with Docker with version 1.0 and the other with version 1.1, and I actually reused my Docker chart for two different versions of Docker image. The problem comes is when I don't want to force my users to specify a version every time they run a Helm install command. That means that the version should come from somewhere. And it comes from this values descriptor that I have. In values descriptor, I will refer to this docker app.name, values image tag, and I will specify the value to be 1.0 or 1.1. The thing is that the values document is a part of the chart, and it's packed with the chart and has a version of its own, which practically means that every time I want to change my Docker image version and I want to change my Kubernetes descriptor version, I have repack it because I changed the value file, and I will have a new version of a Helm chart. So what we end up with is practically, if we don't want to specify a version every time we install a Helm chart, that we have to have a new version of chart every time we want a new version of our Docker image. Does it make sense?
Believe so. I'll wait for follow-ups. We're running a little short on time, so we might run over a little bit if people want to hang around. I do want to ask a question to Desmond. Before digging a little bit deeper into the topic, I want to shift a little bit. Desmond asked, what do you recommend for companies that need to install Helm on customer sites, right? And when there's limited internet access on that site?
Yeah,
Should the company go ahead?
That's a great question, and it actually goes directly to the title of our discussion: how to make Helm enterprise ready. Unfortunately, today we didn't speak about best practices of introducing Helm into enterprise, but instead how to make the tool itself ready for being implementing with those best practices. But we, as JFrog, 5,000 customers, the majority of top 500 and what's not, see those questions and answers those questions every day. There are practices like air gap that allow you to have a completely disconnected DMZ while still using all those dependency managers which interact with central repositories. It's just unfortunately not the scope of this webinar. Feel free to contact me. My Twitter handle is right on your screen, and I will be happy to connect you with people who can actually explain some of those best practices of implementing Helm in enterprise environments.
Awesome. One last one, again, back to the, I guess, the question of templating and descriptors. Any good advice on managing different value YAML files, Helm charts, release deployment management?
Yeah. So there are a couple of aspects in managing values file. The first, on the first level, the management of YAML files, of value files, is having them inside the charts, right? So as we mentioned, we don't manage them separately. They are part of our chart, and they're versioned with the chart itself. And the values that are provided there will be the default, will be kind of a production value, what we actually want to. We can have different sets of these value files based on our environments. For example, we want different set of values for our staging, different set of values for our testing, etc., etc. And those can be used when the Helm charts are deployed to those different environments. The easiest way to do it is just having them in different repositories in your repository manager. So again, if you're using something like Artifactory, you will have different repositories for different stages. You'll have a repository for testing, for staging, for pre-production, for production, and each and every one of them can have different set of values file which actually match the environment that we are going to install our Helm chart to.
Okay. One one last question here. Can you please describe how to upgrade image version using Helm?
Yeah, so the upgrade of the image version is very, very simple. You basically change the value in the values YAML, and then you pack a new version of chart with this new values file, and then you deploy it to your registry, and you got yourself a new version of the Helm chart, which will eventually deploy a new a right version, a new version of your Docker or container image, should I say. It's basically
Awesome.
changing the value and repacking it. Yep.
Yeah, yeah. That brings us to the end of today's webinar. Thank you all who attended. Check your email. We're going to be sending you a link to the video. This was recorded along with a link to Baruch's deck. So thank you all very much for attending. Baruch, thank you for presenting, and thanks to the CNCF and Caitlin in the background for helping facilitate all this. Hope to see you again on our next one, and thanks again.
Thank you very much for having me. Bye-bye.